Hello friends, now let's study about analog communication. The basics of communication we have just seen in the last video. Now we'll start with analog communication. In analog communication we have the message signal and the carrier signal in analog form. Now what is analog? An analog signal is a signal which is continuous both in time as well as in amplitude. This is amplitude and this is time. Now this signal is continuous in both time as well as amplitude. At every point of time we can have a different or some amplitude value. This is called analog. Okay, so in analog communication we have three types of uh, analog communication. Okay, let's see what a signal can have, the attributes of a signal. Consider a carrier signal C of t as AC cos of 2 pi fct plus phi. This is a basic sinusoidal signal. Okay, so it has three attributes. One is the amplitude, one is the frequency, and the other one is phase. So to modulate a signal we can vary the amplitude, frequency or phase of the signal, of the carrier signal, to send our message. So by this we have three types of analog communication. First one is amplitude modulation. In this we vary the amplitude of the signal by the message signal. Second is frequency modulation. And third one is phase modulation. In frequency modulation we vary the frequency of the carrier signal in accordance with the message signal. In phase modulation we vary the phase of the signal. So in this video we will study about amplitude modulation. This is also called AM, amplitude modulation. So as the name suggests, we have to vary the amplitude of the carrier signal with respect to the message signal. Let our message signal be m of t. Okay, so some m of t like this, and our carrier be m of t is our message signal. Message signals are usually low frequency signals, okay, and carrier signals are usually or most of the time they are high frequency signals. So a high frequency signal like this, if we modulate this we will get s of t, which will be something like this. As this is amplitude modulation, the amplitude of the carrier should vary with respect to the message signal. So it will be like this. How this has been shown, this is the message which is now hidden in the signal. Okay, so this signal has to be transmitted over the channel. Okay, if we see in case of frequency domain, suppose the m of t looks like this in frequency domain, and carrier signal is, as we can see, it is a high frequency signal. We can represent it as something high frequency values like delta for cos of 2 pi fct. Okay, so it will be at fc and minus fc. If we modulate it, we will get this signal shifted to fc by in positive frequency, and the negative frequency we'll get something like this. So we have translated the message signal to a higher frequency. This is called modulation. So in amplitude modulation we have further types. First one is DSB FC. This is double sideband full carrier, means we will have the both upper as well as lower sidebands, and the carrier will be present. Full carrier implies carrier will be present. SSB FC, sorry, DSB SC. In this we have double sideband with suppressed carrier. The carrier will not be present. This will be like this. The carrier will not be present. In third we have SSB SC. In this we will have only single sideband. The other sideband will be removed by the modulator. In fourth type we have vestigial sideband, like we will send a part of message signal, not the complete message signal. Okay, now let's study about DSBFC, or simply the amplitude modulation. So a signal C of t is our carrier signal AC cos 2 pi FCT. Okay, the FC is a high frequency signal and AC is our amplitude. Now S of t can be represented by this is the basic signal, general signal for the transmitted amplitude modulated signal. Here this part is the amplitude, okay, and this is varied with respect to the message signal. Here Ka is a constant and it is called amplitude sensitivity. If we expand this, we will get AC cos 2 pi FCT plus AC Ka m of t cos 2 pi FCT. This is our carrier. As you can see from this equation, this is our carrier and this is the modulated wave which we are sending. This consists of the message signal. Now if we convert it into frequency domain, we will get AC del of f minus fc, the Fourier transform of cos 2 pi fct, plus del of f plus fc divided by 2, okay, plus the Fourier transform of this AC Ka. Fourier transform of this will be m of f minus fc plus m of f plus fc divided by 2. So this is the Fourier transform of the amplitude modulated signal with signal m of f of c. So now for the study we will study about single tone modulation. Single tone modulation. In single tone modulation we have m of t as a single frequency signal, message signal. So this will be like am cos 2 pi fmt, where fm is the frequency of the message signal and am is the amplitude of the message signal. If we put this equation into this, we will get AC 1 plus Ka